This video is for Math 111, and this is on the topic of solving systems of equations with matrices. So we've talked the past couple days about solving systems of equations. First, just the two equations with two unknowns, which is pretty straightforward. And then we talked about some word problems that involved systems of equations. Now we're going to get into a little bit more complicated problems. So this is sort of, and this is where we're going to stop too. We're not going to go past this in this class. If you go on in mathematics, you might re-encounter these ideas in a class called linear algebra, which digs into these concepts pretty deeply. And some of these ideas are really applicable if you ever get involved in computer animation. You'll see matrices used extensively. But anyway, let's talk about how to use these to solve systems of equations. So first let's look at problem number 2. Let's see here. So we've got a system of 3 equations with 3 unknowns, x, y, and z. Okay. Let's see here, x plus 2y plus 4z equals 7. All right, so we've got 3 equations, the 3 unknowns, and then these 3 pieces over here. So the idea of using matrices to solve these, so first of all, a matrix is a grid, okay? And it's usually enclosed in these brackets, and you can set it up. We're going to be using 3 by 3 matrices and 3 by 1 matrices, okay? So each matrix is a grid. They can have different sizes, and they can be used for different purposes. What we're going to do here is we're going to represent the coefficients of these variables in the first matrix. So, in the first equation we've got 1, 1, and 6. And in the second equation 1, 1, and 3. And in the third equation 1, 2, and 4. Okay? Now this matrix simply represents the variables, x, y, and z. And over here we have the answer matrix 3, 3, 7. And the idea here is that if you multiply this times the x, y, z, it gives you that first equation being equal to 3. Take the second one times the variables, makes the second equation equal to 3. Third one times the variables makes the third equation equal to 7. Okay. Now, what's nice about this is that if we set this up using the calculator, okay, what we can do, now the process for doing this by hand is very complicated, but we don't have to worry about that. What we're going to do here is we're going to multiply by the inverse of this matrix on both sides, okay? These will cancel out. Then we'll be left with x, y, z on this side, and whatever our answer matrix is on this side. That'll give us the values for x, y, and z. All right? Hopefully this will make more sense when we work through this example. So, let me pull up the calculator here so you can see how this is going to work. All right, so let's get the camera focused on the calculator. All right, so to access matrices, you can see it's right there, right under the math key, so it'll be second, and then x to the minus 1 will bring up matrices. So, let me erase this so we start with a blank screen. Well, I'm not going to be able to do that. But I just wanted to make my screen look exactly the way that yours would have. It's not going to let me do that. But in any event, So let's go in. I just changed the sizes of the matrices. So there's matrix, so second, and there we go. So what we want to do is we want to edit, so arrow over, edit matrix A, and we want to make it a 3 by 3 matrix. So you have to type in 3, enter, 3, enter. Now there's those 9 positions. Enter the numbers that we've got in that first matrix. 1, enter, 1, enter, 6, enter, and so on. 1, 1, 3, and you have to hit enter after each time, and then 1, 2, 4. Okay, so there's our coefficients matrix, and then we quit, and then we'll go back into the matrix section there. And you can see A is now a 3 by 3 matrix with the answers that we put, or the entries that we put in there. Now we want to edit B. So you can arrow down to number 2, choose B. We need to change it. It's going to be a 3 by 1 matrix, and its entries are going to be 3, 3, and 7. Okay, so now we've got these entered as matrix A and matrix B. So let's go back to the board here and take a look at this. So this one right here is matrix A. This one over here is matrix B. So what we're going to want to do with the calculator is multiply A inverse times B. That'll give us the answer matrix. Okay? So we'll go back to the calculator, and I'll show you how to enter that, make that calculation. Okay, get the focus on here again. There we go. All right, let's see here. So we need to go into the matrix section again. There it is. This time we just want to choose A by hitting enter, and then you want the inverse, which is right here. Inverse, and then hit times. And then we want matrix B. So we have to go back into the matrix section. There it is. You can just choose number 2, or you can arrow down to choice B. And there it is. A inverse times B. There's our answer. X is -1, Y is 4, Z is 0. Quite a bit easier than solving it ourselves. And let's see here. So, -1, 4, and 0. So does that work? -1 and 4, and then 6 times 0 is 3. Good. And then again, -1 and 4, 3 times 0 is 3. Yeah. -1 and 2 times 4, this is 8 minus 1 is 7. And again, the Z is still 0. Okay, so there's our solution. X is -1, Y is 4, Z is 0. All right, so let's take a look at a couple more examples here. And like I said, you know, the ideas that go behind this, there's a lot of them. And there is a, you know, major 300 level undergraduate course that covers some of these ideas in a much more comprehensive way. We're just kind of looking at how to use these ideas to solve a system of equations that's a little bit more complicated than we might want to solve by hand. Excuse me. All right, well, let's look at a couple more. In problem 4, we start out x plus y plus z equals 4. X plus y, oh wait, I'm looking at problem 6. All right, -x plus 2y plus 3z, there we go, equals 17. And 2x minus y equals -7. There's no z in that third equation, so we'll put a 0 in there for z when it comes time for the coefficients. So, in terms of matrices, what we're looking at here is 1, 1, 1, negative 1, 2, and 3, 2, negative 1, and 0. So those come from the coefficients for all these variables, and the missing one gets a 0. And then we've got x, y, z, and this should equal our answer matrix for 17 and negative 7. Okay, so let's get these entered as matrix A and matrix B on the calculator. Okay, so now we need to go back in to the matrices and arrow over to edit matrix A, and it's still going to be 3 by 3, but we need to put those new numbers in there. 1, 1, 1, and then negative 1, and be sure to use that negative sign and not the subtraction sign, 2 and 3, and then 2, negative 1, and 0. All right, so there's our matrix A, and then we can go back to the matrix, and we want to edit matrix B. Edit, and then matrix B, still going to be a 3 by 1 matrix, but now it's going to be 4, 17, and negative 7. Okay, so there's matrix B. And now we want to make the same calculation now that we've changed those numbers. So we go back into matrix, choose A, get its inverse, x to the minus 1, inverse, and then times, go back in to the matrix, choose matrix B, and there we go, A inverse times B, and there's our answers. X is negative 2, y is 3, z is 3. And again, the idea here is that we're multiplying on both sides by A inverse. So these cancel each other out to make 1. So what's left on this side is x, y, and z. And on this side we get A inverse times B, which was, let's see, negative 2, 3, and 3. So, x is negative 2, y is 3, z is 3. Does that work? Let's see, 3 and 3 is 6, minus 2 is 4. Good. This will be 9 and 6 is 15, minus 2, minus 2, yeah, gives us 17. This is negative 4 minus 3, negative 7. So, it checks out. All right, that's problem 4. Let's skip problem 6, we'll look at problem 8. Okay, so problem 8, 2x plus y, and I'll leave a gap there for the z, and then 2x minus y plus z equals 6, and then 3x minus 2y plus 4z equals 11. All right, so now we're going to make our A matrix 2, 1, 0, 2, negative 1 and 1, 3, negative 2 and 4. Then we've got our variable matrix, and that should equal our answer matrix 7, 6, and 11. All right, so we want to get this entered as A, this entered as B, and then calculate A inverse times B. Let's see how this goes. All right, let's see here. So we need to get this this going again? There we go. All right, so go back into the matrix screen, and we want to edit matrix A. Still a 3 by 3, but now we want 2, 1, and 0 across the top. 2, -1, and 1 across the middle. And 3, -2, and 4 across the bottom. All right, so there's matrix A. And then we go back to the matrix screen, and we want to edit matrix B. Still 3 by 1, but now our answer matrix is 7, 6, and 11. All set to go. And then we want to calculate, choose A, inverse, and then times, there it is, times, go back into the matrix page, B, A inverse times B, 3, 1, 1. So X is 3, Y is 1, Z is 1. So these cancel out. We get X, Y, Z equals 3, 1, 1. And does that check out? Let's see here. So 6 and 1 makes 7. This will be 6 minus 1 is 5, plus 1 is 6, okay? 9 minus 2 is 7, plus 4 makes 11. Okay, good. So that one is all set. Let me make sure I got my focus back on the board. Okay, good. So let's look at one more here, problem 10. All right, problem 10, we've got 10x plus 10y minus 20z equals 60. 15x plus 20y plus 30z is negative 25. And then negative 5x plus 30y minus 10z equals 45. So, first thing we want to do is represent this in terms of matrices. So our matrix A will be 10, 10, and negative 20, 15, 20, and 30, and then negative 5, 30, and negative 10. Then we've got our variable matrix and the answer matrix, 60, negative 25, and 45. All right, so there's the setup. So we want to enter this as matrix A, this is matrix B, and then we're going to calculate A inverse times B. So let's see how this goes. Okay, so there's the focus. We want the matrix screen, and we want to edit matrix A, still 3 by 3, but now it's 10, 10, and negative 20 across the top. 15, 20, and 30 across the middle, and then negative 5, 30, and negative 10 across the bottom. Okay, there we go. Now we're going to go back to the matrix screen, and we're going to edit matrix B. Still 3 by 1, but now we want 60 on top, negative 25 in the middle, and 45 on the bottom. All right, so now we quit, and we calculate, go back into the matrix, choose matrix A under names, and then do the inverse times, and then we got to go back in and choose matrix B. Matrix B, and there we go. X is 1, Y is 1, Z is negative 2. 1, 1, negative 2. So is that right? Let's see here. 10 and 10 is 20, and then plus 40 gives us 60. Good. 15 and 20 is 35. 35 minus 60 will give us negative 25. 30 minus 5 is 25, and then this will add 20 onto it, giving us 45. Okay, so like I said, we're focused on just how to use matrices on the calculator to get us solutions to these systems of equations. And as I mentioned, there are a lot of ideas that go behind this process, and there are also a lot of ideas that are connected to this process. And as I mentioned, if you're interested in those, I recommend the linear algebra course, which covers a lot of these ideas. And matrices are applied in a lot of different situations, like I mentioned, specifically including computer animation. How computer animation is controlled, has a lot to do with getting matrices set up to do that. All right, as always, if you have any questions on how to solve these problems, please let me know. Thanks very much.